Okay, so we just wrapped up our testing with the MAINGEAR Epic180 water cooling system. As we said, we compared it to the Corsair H70 as well as to the Intel cooling system that they're sending out with all of their Sandy Bridge E processors. We set this up, we ran it on a Gigabyte G1 Assassin 2. We overclocked our processor to a static 4.5 gigahertz using the exact same settings between all of the three coolers just to get an idea of exactly what kind of temperatures we would get out of each one of them. We maintained our temperature inside the lab at about 76 degrees Fahrenheit. That's 24.4 Celsius for those of you that like to read everything in Celsius. And then we ran our different testing. Our tests consist of 30 minutes at idle to get a baseline for the CPU temperature at that point. We also ran HyperPi, which is like running SuperPi on every core in your processor. So with the Intel 3960, it's running 12 instances of SuperPi, 2 per processor core. This maxes it out, gets it up to 100% very quickly, and raises your temperatures fairly fast. We also ran 3D Mark 11, which is a simulation of gaming. We ran that test back-to-back twice, and we took the maximum temperature after the second run was completed. Our third test was Lightwave 3D 9.6 64-bit edition. We ran our standard 4K single frame test, and then we recorded the temperatures after the second run of that test, and that was the max temperature to give an idea of how quickly these can heat up and how efficient these coolers are at maintaining a stable temperature. We ran the test both at stock speeds and of course at that static 4.5 gigahertz overclock, which up until this point has been pretty much the maximum overclock we've been able to achieve. Now in our testing we found that overall the MAINGEAR Epic180 was a much better cooler. It was able to keep things coolers probably between 2 to 3C in some instances, and it also produced less ambient heat into the room, as we found with like the H70 or the Intel. Physically touching the unit, we found that it wasn't as hot, so it's not going to produce as much heat inside your case, and it's going to be a little bit more efficient in that regard. Also, we have to take into consideration the method that MAINGEAR puts these coolers in. With the Epic180, of course you're going to have this at the center line of the case. Towards the bottom, it's going to push the hot air and allow it to rise up. With the H70 or with the Intel cooler, this is going to be along the back of the case just behind the CPU. In some cases, it's going to be directly below the power supply. It's going to allow heat to pool, and you're going to see differences in temperature if you use these inside of a case exactly the way they're intended. Unfortunately, the Epic180 is not available for open purchase as a static part, so the only way you're going to get this is inside of a shift system, and of course that's going to limit what you will see out there in different cases. It's going to be optimized for cooling in there, which is a great thing, because even standing in an open room with no fans and no additional airflow, it still does a great job at keeping our 3960 cool. With the Epic180, one of the things that we found that was an added benefit that we actually didn't anticipate was the size of the head, and the way the cooling head has been manufactured, it doesn't get as hot as the other two. With the H70 and with the Intel cooling system, what we found is these heads tend to get hot and they heat up the heat sinks in the area, and thus create additional thermal load on your voltage regulation system. By having this and having the head built the way it is, it does keep that temperature reduced in that area, which is going to give you an overall benefit and better performance in the long run, especially for overclocking. Now, one thing that's important to note with our testing is that we don't just record the overall temperature of the CPU, which can be misleading. The overall temperature can be important, but it's not going to be as important as the individual cores that are inside the CPU. We found that with our particular 3960, we have one core that actually runs hotter than the other, usually between 2 to 3C. And this can create problems when you push the whole CPU to a certain speed. Pushing it to 4.7, we've seen that core gets closer to the actual thermal threshold of the processor, which is why we have instabilities once we start reaching those speeds. Of course, that's due to the amount of voltage that we have to push through, the CPU PLL voltage, and all of the little ancillary voltages that you need to make sure you have stability. With that in mind, we found that with the H70 and the Intel, this particular processor core tended to get hotter than what we saw in the Epic. So the Epic was maintaining a much cooler overall temperature between all 6 cores that are in there. Again, this is due to the head design. As you can see with all 3 lined up here, you just have a much flatter and a much cleaner surface with which to make contact to that larger 3960 die. Now, moving forward, we do plan to maintain this in the lab, and it's going to be the cooling system that we use with all of our Intel processors moving forward. We do hope to get an AMD one in the house as well, so we can show you what this can do for your AMD systems. but it's also going to be there to benefit us and see exactly what we can get out of our CPUs. So that wraps it up for the Epic 180. Again, we found that it is a much better and more efficient cooler than the other designs that we have here. And if you click on the link below in the description, you'll get to see all of the testing, the results, the individual cores, as well as a little bit better description of how we tested each individual system so that we could get our overall result here.